The AMD Strix Point chip is finally in a mini PC that's under $1,000 in this Geekom A9 Max that many of you have been asking about. It's got a Ryzen AI9 HX370. We've already seen this chip show up in a bunch of other machines, including the Asus ZenBook S16, which I reviewed before. DDR5, 32 gigs, and this one comes with 2 terabytes. But what makes it stand out here is its flexible memory controller. Built on a 4nm process, it can be paired with either soldered RAM, like Apple has in their chips, or upgradable RAM. And that's exactly what's inside this A9 Max. You can upgrade it all the way to 128 gigabytes. I've got a 96 gigabyte kit right here, which we'll be testing out a little bit later with some local LLMs. Product contains a button cell or coin battery. Do not eat it. We've got slightly different styling from Geekom for this series. I'm kind of liking it. A lot of ports on this thing. Wow. We've got an SD card reader. We've got 4 USB-A ports on the front and a headphone jack, a power button, Kensington lock, and look at the back. We've got 2 2.5 gig Ethernet ports here. You can link them up together to make 5. Kind of wish we had 5 or 10 on each one of these at this point, or at least on one of them. 2 USB 4 ports, 2 HDMI ports, 2 more USB-A ports, and of course, power plug right there. This new breed of chips is really efficient, and right now at idle it's using only 3.7 watts. The synthetic Geekbench score is kind of right in the middle of all the different mini PCs that I've tested, maybe a little bit above average. Single core 2891, multi-core 13922. It's not the top result that I've seen using this chip. That goes to the Beelink Ser9 Pro, and that one has soldered memory, and I wonder if that has something to do with this test. Although this is mostly a CPU bound test, so probably not. Let's go to Speedometer 3.1, which is a web dev related test, and this simulates running an application or many different kinds of applications using different JavaScript and TypeScript frameworks in the browser. 37.4 is the result for Speedometer 3.0. I wanted to get this score because I wanted to compare it to all these other mini PCs that I reviewed earlier in the year to show you that the only thing that beats that score are the Mac Mini M4 and the Mac Mini M4 Pro. Everything else kind of falls under it. So really good score there that represents single core operations. Another test that I do often, sorry about the clicking here, I'm just cloning this repository called the Web Tooling Benchmark. An oldie but a goodie, as I like to call it, because this kind of represents a lot of tools that us web developers use under the hood. There's tools like Babylon, Chai, CoffeeScript, Prettier, Terser, TypeScript, Uglify.js. These are all the kind of tools that are pretty much obfuscated in the modern JavaScript frameworks that we use. But I still like to run it so that we get some idea of how to compare the different computers to each other. There's the final result, and it's not super great, I gotta say. TypeScript is at 19.68 runs per second. That's the one I compare most of the time. And geometric mean is 18.62 runs per second. A far cry from what Mac Mini can get you, the M4 or the M4 Pro. Definitely lower than the Snapdragon X Elite Dev Kit, which you can't really get because they discontinued it.
So why are you talking about it, Alex?
Because I kind of wish that it wasn't discontinued. Whatever. It's pretty much along the lines of the Beelink Ser9 as well, and they are using the same chip. But remember, this one doesn't have the soldered memory. This one has upgradable memory. So even though they're getting the same score, hey, apparently memory, soldered or not, has no effect on this particular test. Let's get a little bit more realistic here though. I'm gonna open up a bunch of tools because, well, as developers, we don't just sit here and benchmark one thing at a time. We often have a number of tools that we're working with. So we have maybe our IDE open, maybe a couple instances of that. So I'm gonna open up Visual Studio, I'm gonna open up Visual Studio Code, I'm gonna open up Terminal here, a bunch of Chrome tabs. Heck, maybe I'll even have a little music player playing over here in the background. I'm also gonna open up LM Studio because, well, it's 2025 and AI is everywhere. In fact, Geekom refers to this A9 Max as AI flagship redefined. And it's also compact power for gamers. It does everything, because why not? This chip is powerful enough to do all those things. But let's switch back to some developer related stuff. I'm gonna build this large monorepo. It's a NX monorepo. We're still in web developer land, which is my bread and butter here. But combined, there are about 26,000 components in this project with 5 shareable buildable packages, 250 components for each of the libraries, 5 Next.js applications. Basically, it's pretty big. Let's run that. The nice thing about these tests is that they're available on GitHub, so you yourself can go grab them and run this yourself if you want to do that and compare it to your computer. And if you have some numbers with your computer stats, you can post them in the comments for everybody to see. To run this, I'm using measure command, which is a PowerShell command, so it allows me to measure the time that this takes to build. And I got 60.99 seconds here. Now this represents more of a project that you would actually have, like a real world project if you're using like React, Next.js. And this is probably more realistic. And we've got 60.99 seconds, which is... I'm a little skeptical of this number because it's really, really high, like way too high. So I'm gonna do that one more time. I'm using the skip NX cache so that the cache is blown away every time I build this monorepo. That's better. 14.2 seconds. That's a little bit more in line from what we've seen before. And this definitely aligns with B-Linksir 9 again, but this time we're using build tools that are going to be single core and multi-core, so this kind of represents a more realistic build. So we're right there in the middle. Let's now switch over to a full-blown multi-core Python algorithm called Mandelbrot. Again, this is available online on Benchmarks Game, and it's this bit of code right over here, pretty short. Mandelbrot was a mathematician that discovered the fractal patterns in nature, and what I like about this algorithm is that it uses all the cores available of the CPU and really pegs them to the max. We'll see what power outage this has as well. So I'm gonna use the measure command again. 16,000 is our parameter. That's what is required here for consistency. And boom. Let's have a peek at Task Manager, shall we? Oh yeah. Look at that, Task Manager not responding. And that's because we're really taxing this system right now. Look at that CPU going nuts on every single processor. And by the way, there are 12 cores here, if I didn't mention that earlier. 24 threads. They were all being used for a total of 33 seconds, 33.29 seconds for this test. This is the first time that we're getting close to the Mac Mini M4 and pretty much matching its performance there. I want to run this again so we can get a sense of how much power is being used while all that craziness is going on. And we're just at about 75 watts of power, peaking close to 80. 33.53, so pretty consistent there. I'm about to go to GTC in Washington, shoulder to shoulder with thousands of developers on the same sketchy public Wi-Fi. My source code and my NAS login are staying private, so Surfshark comes with me. One click and everything, git push, SSH, Docker pulls, travels inside an AES 256 encrypted tunnel. Clean Web quietly swats the trackers and junk ads that slow pages down. Surfshark keeps no logs, independently audited by Deloitte, and servers are RAM only, so a reboot wipes them clean. My favorite perk? Unlimited devices. I run it on this MacBook Pro, the mini PCs in the office, and my phone so I can upload to my NAS when I'm on the go without the ISP poking at my traffic. Go to surfshark.com/AlexZiskin for 4 extra months free on your plan, and there's a 30-day money-back guarantee, so it's risk-free to try. Stay private, stay productive, and now back to the video. I'm gonna build this project called Umbraco. It's a CMS that's been around for a little while. I've actually built a couple of projects on it, and this is fully open source and available on GitHub right over here. It's called Umbraco CMS. Actually still being updated 3 hours ago. That's good to see. Pretty large project, real project. Let's take a look. I'm gonna build it right here. Boom. And now, this is the part that you don't normally see. It's building. I'm gonna go on Twitter or something like that. So after running this and getting 196 seconds, which is a little bit on the long side compared to some of the other ones, I've realized that while this may be a good comparison point for you to know, if you're trying this out right now, this is an ongoing live project and I don't have a single timestamp of where I built this during those last builds. So it's not going to be apples to apples comparison because other features might have been added to the CMS during this time. But now you have this data point and you can run your own tests if you'd like. Since we're in .NET world, I'm going to build a very large project I shouldn't have called this large project. I should have called this huge project. Oh well, too late. Basically, it's a .NET 9 application that generates 100,000 namespaces and classes and builds them all. And in order for the compiler not to obfuscate away all this stuff, I made sure I'm using only the kinds of functions and calls that cannot be obfuscated by the C# compiler. And let's go. Okay, looking pretty good here. 95.6 seconds for the build. Of course, it doesn't come close to the M4 Pro numbers, but this is pretty good. Just a little reminder that the M4 Pros start at $1,400, and that's only with 24 gigabytes of memory and 512 gigabytes of storage. If we upgrade just the storage to 2 terabytes, which is what this Geekom machine has in it, then we're up to $2,000. Not that I'm trying to make excuses or anything, but yeah, a different class machine. Let's switch gears a bit and talk about large language models and what this AI machine can do. The AI that's usually referred to in these machines is referring to the NPU. So these new breed of machines have the NPU, which is something that we hope to be able to use in the future, and there are libraries that take advantage of that. They're highly specialized libraries. They usually target only that particular CPU architecture. Now, the tools that we generally use are tools that run on the GPU and the CPU. Tools like LM Studio. And this is a tool that's cross-platform. It runs on Windows, Mac, and Linux. So does Ollama, if you've heard of that. And I've made videos about both of these before, the installation process and so on. So we're just gonna run this tool, which is supposed to use the GPU and the CPU. The Strix Halo GPU only gives it 4.5 gigabytes of dedicated GPU memory, so we're gonna be very limited. Let's take a look at what's available here. I installed a couple of models here from OpenAI's GPT OSS 20B, 120B. Those are sparse models. They're a mixture of experts models, which means even though they have a lot of parameters, only a subset is activated at one time, requiring less memory, which is good for our case. Then there is Llama 3.3. That one is a dense model, so it's a 70 billion parameter model, but all the 70 billion parameters are loaded at once. Not sure if it's gonna run on this or not. Most likely not. If it will be, it's going to be very slow. And then there's a couple of coding models like the Qwen 3 Coder 30 billion, which is something I often use myself, and I've shown it on the channel before. It's a pretty good coding model, coding assistant. Let's start with the smallest one on disk, which is this OpenAI's GPT OSS 20B. I'm going to manually choose to load parameters, and I'm going to see what it's recommending. LM Studio is suggesting that I offload only 17 out of the 24 layers to the GPU, which means it's not fitting in the GPU fully. And that's even at the small context, that's the default 4096. A quick check at the hardware tab in LM Studio suggests that we are running Vulkan here, which is going to be utilizing the parallel processing ability of the Radeon 890M graphics. That's part of the CPU there, part of the package, the integrated GPU. Don't expect too much here, but I'm going to load the defaults and see what we get, because for some, this might be all they need. And it loaded just fine. Let's create a new chat. I'm going to use this architecture prompt, design a scalable web architecture for an e-commerce platform, and so on and so forth. Reasoning effort, I'm going to leave at default, which is low. And let's go. This is a thinking model, so it's going to first start thinking, and it's going pretty decent. Let's take a look at what's happening here in Task Manager. You'll see that the GPU utilization is 65% here because we can only get 3.3 out of the 10 gigabytes or 11 gigabytes in there. Most of it is happening on the CPU, unfortunately, though, which is going to slow us down considerably. There's the memory load right there. 22 out of 27 gigabytes of the system memory is being used, and it's doing the printing. Is doing these graphics, high-level architecture design diagram. That's pretty good. All right, I'm gonna stop this because we have enough now to get kind of a token count. We're getting 13 tokens per second here. I'm gonna try and push it, see if we can get more layers loaded onto the GPU. It's probably not gonna work. It's gonna crash most likely, but let's see if it lets me. Hey, did that actually load? Wow, okay. Let's try that again. Huh, that's actually working. I'm really surprised right now. And we're getting more GPU utilization here, 95. Even though this model is 11 gigabytes in size, it's only using a small subset for the mixture of experts kind of architecture. We just happen to be able to fit all of it inside the GPU, which is great. No complaints there. And it is going quite a bit faster. Now, as I've said before, I am comparing only speeds here, not the quality of the output, because that would be a very different kind of video. We're just comparing the performance. 20.25 tokens per second here. That's pretty decent, considering we do not have discrete GPU hooked up to this at all. Power usage is pretty much the same as we've had before, just under 80 watts. When we were maxing out the processors, now we're using maximum GPU. So that's actually relatively low for the power usage here. It's not a silent machine though. And when I'm pushing it this hard, you can definitely hear the fans. Let's check out this Llama 3.3, and it's suggesting that I offload 12 out of 80 layers to the GPU, and it says fail to load the model. I do have strict guardrails on. Let's relax that a little bit and see if the model loads at all. Nope, not letting me load that model. And yeah, I could turn the guardrails off completely, but then you have an unstable system. Let's try the 120 billion parameter model and see if that works at all. Nope, not at all. But I do have some extra memory. Here's the NVMe SSD that you can swap out to, and there are the RAM modules right there. Now, these are not crucial, but they do seem to be DDR5 5600, which is what I have here. I just have 48 gigabyte modules. So I'm gonna swap those out. And boom. Okay, wow, that worked a little bit too fast. I was expecting it to not post that quickly for the first time you change RAM, but it did. And let's take a look at this. There we go. 91.6 gigabytes. I thought I was supposed to have 96. What happened to the rest? We're still only getting 4.5 gigabytes of GPU memory. That's fine. Let's go back to our models. Where was I? I was loading Llama 3.3, 70 billion, and now it's telling me that I can offload 47 out of 80. Let's try it. Not sure why LM Studio is letting me load 47, even though the GPU only has 4.5 gigabytes of dedicated GPU memory available, but it does say GPU memory down here, 50, which is something that modern chipsets will let you do, is they'll kind of fake the sharing of the memory, and it did let me load it. Wow, it's paste in our architecture prompt. This is gonna be slow, I'm just warning you right now. By the way, if you have a guess as to how many tokens per second this will be, before you look ahead, write it down below. I'll be curious to see if you're right or not. I'm gonna guess 2.5 tokens per second, all right? It's printing. It's actually working. A 70 billion parameter model, a dense model, is actually working, which is pretty cool. Oh, I'm wrong. 1.63 tokens per second for that one. Okay. One more. Let's do the mixture of experts, 120 billion parameter OpenAI model. This one right here. It says we can offload 14 out of 36. Let's load it up. Come on. You can do it. By the way, I got new furniture. I saw this at the store and it just had my name on it, so I had to get it. It loaded. That's great. Oh my gosh. Okay. Getting too excited. Let's run this prompt. And it's working. It's going pretty decently quick. Look at that GPU at work. Only 34% utilization, but we're about to increase it a little bit more to see what we can push. Most of this is happening on the CPU, yes, but it's still going pretty decently quickly. I'm gonna guess 15 tokens per second on this one. Let's stop this and see what happens here. 13.12. One more load, and this time I'm gonna offload a little bit more. Should we go all the way? Let's go all the way and see what happens. Boom. It's probably gonna fail, but maybe not. I was surprised last time. Yeah, failed to load the model. I'm gonna tweak it just a little bit more here, and I'm gonna say, let's offload 30 layers to the GPU. Not letting me do it. Hardware, guardrails off. Okay, now my computer might crash, but you know, I tried it. I tried it for you. This is the kind of stuff that I do here on this channel. So if you appreciate that, leave a comment just under the like button. I'm willing to crash my computer so that you know what happens. Ugh. Failed to load the model, folks. This is just not happening here. I'm gonna go a little bit lower to 26 here. There's gotta be a good balance, right? We can eke out a few more tokens per second to get that 120 billion parameter model working. Look at that memory struggling. If it starts going downhill, we know we failed. It loaded. All right, here we go. Come on. And there it goes. It's running, generating. We're using 77% of the GPU. It ranges, but that's pretty decent. And of course, a lot of it is running on the CPU as well. We're using 84% of the CPU. And we're getting 11.4 tokens per second on a 120 billion parameter model. MOE. Mixture of experts. Anyway, this is fun experiment, fun little machine. We've seen a lot of machines come out that are in the $2,000 range to $3,000 to $4,000 range for mini PCs. They're getting a little crazy, right? There's still a bunch that are in the $200 range, but those are running really old processors. Now we're getting a mixture somewhere in between, which is giving us good processing power right there, and the price is not terrible, which is under $1,000. And that's what this one is. But to see that test where I do a bunch of mini PCs against each other, watch that video right over here. Thanks for watching, and I'll see you next time.
Yeah.